All right, in these notes, we're going to talk about binomial multiplication, which, as you'll see, is essentially the distributive property. So up to this point, when we have used the distributive property, we've mostly used it to multiply a monomial by other monomials, binomials, trinomials, right? We've distributed a monomial to multiple things inside parentheses, but we haven't used it to multiply a binomial by a binomial, and we'll see how that works in these notes. So to multiply polynomials in general, use the distributive property in this way. Now today we're focusing on binomials. Those are two-term polynomials, but in our next notes we will move on to bigger things. So the way this works is probably the way you'd expect. You take the first term in the first binomial, multiply it by the first term in the second, and then by the second term. And then you take the second term in the first binomial and multiply it by both of those terms as well. So you end up with 4 terms in your first result. And then after you do that, you want to check for like terms, make sure there's nothing you can combine. Now this is often called the FOIL method, which I usually don't focus too much on. But the way it works is the first term is f because you use the first term in each binomial. The second one is O for outer, where you use the outer 2 terms, and then I for inner, the 2 inner terms, and then L for the last 2 terms. Now the reason I don't usually focus on the FOIL, calling it FOIL, is because when you get to higher polynomials like trinomials and 4 terms and so on, the acronym doesn't work anymore because there's more than 4 multiplications that you're doing. But it is handy for remembering for at least this first one if you've done all 4. But I think just know you're going to multiply every term in the first one by every term in the second one, and then check for like terms. So let's actually see how this works. So for example A, we have x plus 6 times x plus 4. So first we do x times x, that's x squared. X times 4 is a positive, so plus 4x. 6 times x is a 6x. And 6 times 4 is 24. Okay, now notice how my middle 2 terms are like terms. I can combine those. And this is often what happens when you're multiplying 2 binomials because typically they are the same degree. You have an x and then a constant, and so you end up with being able to combine these middle 2. It won't always work out that way, but often it does. So just make sure they are like terms and then combine them if you can. So there's our final result for the first one. Let's look at example B. Same idea. Y times y, that's y squared. Y times 2, 2y. Negative 7 times y is negative 7y. And negative 7 times 2, negative 14. Notice I kept that negative sign with the 7. That is a negative 7. So make sure you use a negative when you multiply. And once again, we can combine like terms right here. So y squared minus 5y minus 14. Okay, example C. M times m, that's m squared. M times negative 1 is negative 1m. And then we have a negative 5. So negative 5 times m is negative 5m. And negative 5 times negative 1 is positive 5. Now you don't have to draw those kind of rainbow lines, but it does help you remember what you've already multiplied and what you haven't. So m squared minus 6m plus 5. All right, let's move on to example D. We have 8k plus 3 times negative 2k minus 1. So Now, this is a slightly different because the first three we did had just x or y or m. There wasn't a coefficient, but here we do. 8k times negative 2k, that's negative 16k. Just remember the rules for multiplying monomials. You'll be okay. This is a negative 1 here, so 8k times negative 1 is negative 8k. Don't forget the squared on that first one, negative 16k squared. Okay, then 3 times negative 2k is negative 6k, and 3 times negative 1 is negative 3. And again, we can combine those middle two terms. So negative 16k squared minus 14k minus 3. Example E. 2x times x is 2x squared. 2x times 6y. Now, we are multiplying two variables here, so 2 times 6 is 12. And then you can just write xy like this. So x times y, it's just xy. And then this is a negative y here, so negative y times x is negative. And it's the same two variables here, x and y, so I like to write them in alphabetical order. Not only does that keep it consistent, but it also helps identify whether or not they are like terms. Because xy and yx mean the same thing, and so they are like terms, so you should write them the same way. And the negative y times negative 6y is negative 6y squared. And again, we can combine those middle two, so 2x squared plus 11xy, 12 minus 1, and then minus 6y squared. Okay, example F. Okay, example F. We have negative 6x cubed times x squared. Again, just remember the rules for multiplying monomials. Negative 6 times 1 is negative 6, and then add the exponents. 3 plus 2, that's x to the 5th. Negative 6x cubed times 3 is negative 18x cubed. And now the second set, negative x times x squared is negative x cubed, and then negative x times 3 is negative 3x. All right, and now we can check for like terms. So negative 6x to the 5th. And negative 18 minus 1 is negative 19. X to the 3rd. And then minus 3x. Now this next section is sort of a special case, although you could probably figure out without having talked about it. So this is where you have a binomial that is being squared. And the important thing to remember is that a plus b squared or a minus b squared, you want to think of that as a plus b times a plus b, or a minus b times a minus b. And if you don't remember the pattern that comes from squaring a binomial, as long as you remember that fact that you can just multiply it by itself, you'll be okay. You can remember the pattern. It does make it a little faster, but it's not necessary. So a plus b squared always results in this pattern, a squared plus 2ab plus b squared. And a minus b squared always results in a similar pattern, a squared minus 2ab plus b squared. But what I would rather you take away from this is just to remember that when you square something, you multiply it by itself. So x plus 4 squared, this is the same thing as x plus 4 times x plus 4. And as long as you remember that, then the multiplication part comes a little easier. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. And this is why there's a pattern, the 2ab in the middle of the pattern, because when you combine like terms here, it is 2 of this 4x term. It's 2 times that term. So we have x squared plus 8x plus 16. So, and you can see how we got that pattern there. A squared, that came from this x squared. And the 2ab, well, x is a and 4 is b, so 4 times x is 4x. 2 of those makes 8x. And then finally, b squared, 4 is b, so that's where we get the 16. So this pattern always shows up, but again, if you don't want to memorize it, you don't need to, you can just write out the multiplication. So x minus 4 squared is just x minus 4 times itself. And as long as you remember that, you'll have no trouble with the multiplication. X squared minus 4x minus 4x plus 16. So very similar pattern, although the minus sign in the binomial makes that second term negative. X squared minus 8x plus 16. So let's try some of these. And again, you don't need to worry about the pattern. As long as you can multiply it out, that will be fine. So x plus 7 squared, remember that's x plus 7 times itself. And we would get x squared plus 7x plus 7x plus 49. And then combining like terms, x squared plus 14x plus 49. Now using the pattern, if you wanted to, you could see that, okay, we have x plus 7 squared, so that's going to be a squared is x squared. 2ab, 7 times x is 7x, and 2 of those is 14x. And then 7 squared is 49. So you can get to the answer without writing as much if you remember the pattern. Let's try the pattern first on example B and then see if our work matches it. So 7y plus 2 all squared. So first we do a squared. 7y squared is 49y squared. And then 2ab, 2 times 7y is 14y. 2 of those is 28y. And then 2 squared, that's 4. Now let's see if that matches the work we do if we write it out. So 7y times 7y is 49y squared. 7y times 2 is 14y. 2 times 7y is 14y. 2 times 2 is 4. And you can see if we combine like terms here, we do get that same trinomial. 49y squared plus 28y plus 4. So we do end up with the same trinomial. So it can make things faster if you remember the pattern and how it works, but again, it's not necessary. But let's go ahead and use the pattern to finish these up so we can get through these last two quickly. So m minus 2 squared, again, this is a minus, so it's a squared minus 2ab plus b squared. That's this pattern here. So m squared is m squared. Negative 2 times m is negative 2m, and then 2 of those is negative 4m. And then negative 2 squared is positive 4. Negative 2 times negative 2, positive 4. So that matches our pattern, and that is what we should get there. And then on example D, 5y squared is 25y squared. Negative 4 times 5 is negative 20y, and 2 of those is negative 40y. And the negative 4 squared is positive 16. So again, the pattern does make it quicker, but if you don't remember the pattern, you can always just write out the multiplication and just use the distributive property. Works just as well. Okay, but just remember, when you multiply two binomials, your initial result before you combine like terms should have 4 terms, and then typically 2 of them will combine to make a trinomial. Not always, but often that is the case.